For this video, we're going to be expanding on the idea of proofs. Okay, so what we've been talking about so far with proofs has been how to prove that two triangles are congruent. And we've talked about laying out our evidence to prove that they're congruent, giving our reasons for our evidence, and then finally proving that the two triangles are congruent. Okay, now y'all have kind of started to get a grasp on this, but we're still going to be practicing it. But I'm going to expand on this where we're going to be proving different things. Okay, so all of our proofs so far have been given information and then asked to prove two triangles are congruent. Okay, I want you to look at the proof on your screen right now. Look at what I've circled or rectangled, I guess, in red. This proof is not asking us to prove that two triangles are congruent. It's asking us to prove that two pieces of the triangle are congruent. Alright, so this is different. This is where we're going to introduce one of our proof blocks that we have not talked about yet. So if you've got your proof blocks with you, get them out and you will find that you have a proof block that has these letters on it, CPCTC. Now I've had a few people who have asked me, what does this CPCTC stand for? And I told them that, we'll get to it, but that it stands for corresponding parts of congruent triangles are congruent. Okay, so I want you to think about that for a second. Corresponding parts of congruent triangles are congruent. Well, I mean, that kind of makes sense. If we've got two corresponding triangles and we know they're congruent, then obviously all of the corresponding parts are congruent. So that's basically what CPCTC is used for. If we can prove that two triangles are congruent, then we can very easily prove that any or all corresponding parts are congruent. Alright, so this is an important piece of information. So I'm going to be showing you in this video how to use CPCTC. So at the bottom, I have started the proof just like we would have in class. You can see that we've got our given information, so let's mark it. We know that AB is congruent to AC, so I'm going to put my tick marks there. We're told that AD bisects BC, and we know that when something bisects, it cuts it in half, so that means that the two pieces of BC are now congruent. And then, of course, we have our shared side, which we also know is congruent. So right now, you should be able to look at this and say, okay, we're going to prove that these two triangles are congruent by using the side, side, side postulate. You can see that I have already laid out our evidence. We know that AB is congruent to AC, we know that AD is congruent to AD, and we know that BD is congruent to CD. So let's give our reasons for these. AB congruent to AC, that one's easy, that's our given. How did we know that AD was congruent to AD? Remember, this was our memorization moment. You've got to know that that is the reflexive property. Okay, so that's our reflexive property. And then how did we know that BD was congruent to CD? We got that from this. We knew that AD bisected BC, so we know that these two pieces of the triangle are congruent because definition of a segment bisector. Alright. And I've already put over here that once we know those pieces of information, we can definitively say that triangle ABD is congruent to triangle ACD. But that's not what we're asked to prove. So what that means is we are not done. Now, we have proved the two triangles are congruent. That's great. If we know that these two triangles are congruent, you can absolutely 100% completely say that angle B has to be congruent to angle C, because if the two triangles are congruent, then the corresponding parts are congruent. So we use our proof block. I gotta do it a little smaller, but in your proof blocks it's the same size. We use our proof block CPCTC to prove that angle B is congruent to angle C. And you're done. So CPCTC is an extension. Okay, we're extending out to the right. Once we've proved that the two triangles are congruent, we can say that any corresponding parts of congruent triangles are congruent. That's our CPCTC, and that allows us to prove that angle B is congruent to angle C. And that's it. Alright, so go to the form and submit your answers, and I will see y'all Friday.